That's 2 practice tests. So let's go through some questions here. So true and false. A lot of times if this is on the test, I'm going to ask you to do a counterexample if it is false. Just to let you know. So I'm going to do that here. True. True or false, I should say. If f of c equals 2, the limit as x approaches c equals 2. That is false. Let's talk about a counterexample. So it's saying if the value at some point c is 2, the limit has to equal 2. That's not true at all. I could do something like that. I mean, just because the value equals 2, the limit does not have to exist. But anyway, there's an example where the value of c equals 2, the limit does not equal 2. True or false? If the limit as x approaches 3 goes to infinity, if x has a vertical asymptote at x equals 3. That is true. Only way you get infinity is, there's only 2 ways to get infinity as an answer. That's if at the end you go to infinity, or if there's a vertical asymptote at a number and you go to infinity or negative infinity type of thing. So that's true. True or false? To find all possible horizontal asymptotes of a function, you must determine the limit as x approaches infinity, the limit as x approaches negative infinity. That is also true. So they're essentially the same thing. Horizontal asymptotes are essentially just these 2 things. True or false? If the limit as x approaches a from the left is equal to the limit as x approaches a from the right is equal to L, then f of c equals L. That is false. It's almost true. If the limits from the left and the right match, the limit has to equal L, but does not. F of c does not equal L. Kind of like the one we had up here. Same counterexample. From left and right equals some value, but the value might be something else. So false. True or false? If f of x is continuous and the limit from the left and the limit from the right equal L, then f of c equals L. That one is true. The key here being it's continuous. If it's continuous, the limit and the if it's continuous, the limit and the value are the same. True or false? If f(x) is continuous on a and b, then f of x is defined on a and b. That is true. That's to sound like you can't have a hole because it's continuous, so you can't have a hole. It's not possible to have a hole if it's continuous. True or false? If f of x is defined on a and b, then f of x is continuous on a and b. This one's false, right? So this one tells you it's continuous. If I know it's continuous, then it's all defined. If I know it's defined, it does not necessarily mean it's continuous. I have a graph that's like a jump. Right? So every value is continuous, but it's not. Sorry, every value is defined, but it's not continuous. True or false? If direct substitution of a limit yields 2 over 0, the function has a vertical asymptote. That is true. Remember, this means vertical asymptote, but that means like this is not indiscriminate. This does not exist, which is a vertical asymptote. Sometimes I want infinity or negative infinity, but that does not exist. True or false? If the direct substitution yields 0, 0, then the limit does not exist. That is false. Right? This is indiscriminate. You have more work to do. True or false? If f(x) is defined on 1 of 4, with f of 1 equals 3 and f of 4 equals negative 5, there must be a 0 in 1 of 4. So this one's tricky, because you want to say true because of IVT. But IVT needs 2 things. It needs to be a continuous function. Well, I should say it needs to be that. So it needs to say this if it's IVT. And this actually does not say that. So for all we know, this could be a jump. It could be the graph I did up there. So you don't actually cross arrow because it's not. Didn't say it's continuous. So that's why it's false. It's a tough one though, because you want to say true. I almost said true. And I was like, it didn't say continuous, so you can't just say true. Okay, the next one. We're going to read graphs limits from a graph. Above, use. Okay, the formatting's off. Sorry. Use a graph of f of x. This is a graph of f of x. Above to find the following limits. Y equals 1 is a horizontal. There's a horizontal right here. So limit as x approaches 0. So here's 0. As you go from the left, you get 0. As you go from the right, you get 0. So my limit is 0. B, limit as x approaches 2 from the left. So here's 2, I'm coming from the left-hand side, so we're coming from this side. It looks like it goes to 5. 1, 2, 3, 4, 5. Limit as 2 from the next one's limit as x approaches 2 from the right. Well, here's negative 2 from the right. From the right, you're going down to negative infinity. The limit as x approaches 2, so just positive 2. So here's 2. From the left, you go to 3, and from the right, you go to 3. So just 3. E, limit as x approaches 1 from the right. So here's 1, and then you're coming from the right-hand side. So it looks like it's going to 1. 1 from the left-hand side, same spot. Limit as x approaches negative 6. So again, it's asking about the limit, not f of negative 6. The limit's up here. So you go from the left, from the right, you're all going to negative 2. Sorry, positive 2. Limit as x approaches negative infinity. So negative infinity, remember, it's our x go to negative infinity, that's this guy. And as you get close to negative infinity, look where your graph's going. It's following that horizontal asymptote. So 1. And then what's f of negative 6? That's a closed value. At negative 6, we put a closed value. Negative 2. And again, sorry, the formatting's off. There's actually another one down here. F of negative 2. So at negative 2, f of negative 2, there's no value at negative 2. So you do that, you can say no value, no solution, whatever. Next one. Draw a function that has a jump discontinuity at x equals 3, then that is left continuous at x equals 3, but not right continuous at x equals 3. So here's x equals 3, so I do a jump discontinuity, so that looks like this. Right. That's a jump discontinuity at x equals 3. Now it says I want it to be left continuous. That means right here at 3, I want the left side to be closed, but not right continuous at 3. Whoa, my graph is off. So let's erase. I'm 1 off. I would mark you down for that. Here's 3. I was like at 4, and then left is continuous. Okay, something like that. Right now, it should be over the whole graph. Next one, draw a function that satisfies the following. Limit as x approaches 4 from the right. So you got 4, and with that from the right is 4. So 4 from the right is 4. Notice because again, I don't know what the rest of the graph is, but I know from the right hand side I gotta hit 4. So the limit as x approaches 4 from the left is 8. So 8. What is with my eyes? 4. There we go. There we go. Alright, so there's 4. I was at 3 again. So there's 4 from the right, 4 from the left is 8. F of 4 should be 3. So f of 4 should be 3. So that's the only closed circle. Then I should finish off this graph. So like this. I mean, go crazy, whatever you want to do. I just got to finish off the graph so it's not just like the little pieces there. The key part here is right here at 4. 4 from the right should be 4. 4 from the right is 4. 4 from the left should be 8. 4 from the left is 8. And then f of 4, that's that closed circle, is at 3. There we go. Is the function f of x equals cosine x, x greater than 0, 1 minus x squared, x less than 0, continuous at x equals 0? If it's discontinuous, state the type of discontinuity. If it's continuous, show 3 criteria. So let's do the 3 criteria. Criteria 1, does f of 0 exist? Well, plug into this guy. Cosine of 0 equals 1. So yeah, f of 0 equals 1. 2, let's look at the limit as x approaches 0. And I probably wrote that wrong. I probably should just wrote f of 0 and then figure out what it was, and f of 0 equals 1, so it does exist. So the limit is as x approaches 0, so I gotta do both limits, from the left and from the right. Left and from the right, there you go. So limit as x approaches 0 from the left would be 1 minus x squared. So you just plug 0 in there, and you get 1. The limit as x approaches 0 from the right, we already did that one, that's cosine of x, and that is 1. Cosine of 0 is 1. So they match, so my limit here just equals 1. And 3, do they equal each other? And yes, they do. F of 0 does equal the limit as x approaches 0 of f. So it's continuous at x equals 1. At x equals 0, not 1, sorry. 1 was with the y value. So it's continuous. In case, graph the function verifier. So we gotta graph the function. So I'm gonna graph cosine. If you remember, cosine starts at the amp and then goes down. Looks kind of like this. It doesn't be a perfect graph, but there is cosine. And then 1 minus x squared. 1 minus x squared is... Right, so cosine looks like this. 1 minus x squared is a parabola up at 1, but it's a negative parabola because it's flipped, so it looks like this. So it'll be like that. That makes sense. So it's like 1 minus x squared is a parabola, but it's opening down at 1. And then we're only taking the side that's less than 0, so we're taking this side. And then cosine x squared is a graph that looks like that, and then that side. Not the best graph, but that's the idea. Prove that f of x takes on the value of pi on the interval from 1 to 3. This is an IVT question. Again, my format is off, I apologize. So it's an IVT question. So if I remember the way IVT works, you want to say it's continuous. So if I was doing this, I would say it's continuous. F of x is continuous because it is a polynomial, which we know polynomials are continuous. Next, I gotta do the work, right? I gotta show that f of 1, that when I plug this into there, I should get something less than pi and one bigger than pi. So we can do it off on the side. If I plug in f of 1 into this one, I'm gonna get 1 cubed minus 1 minus 5. So 1 minus 1 minus 5, which is just gonna be 5. If I do f of 3, I'm gonna get 3 cubed is 27 minus 3 minus 5. So I get 19. The first one was negative 5. That would have been a problem. I'm sure the negative. So we got negative 5, we got 15. So there must be a pi between these two, right? This is continuous. It's a continuous graph. And I have something less than pi, I have something more than pi. So yeah, pi must fall between. So you go, okay, pi IVT, since f of 1, remember you don't use the y value, you use f of 1 instead. So like f of 1 is less than pi is less than f of 3. There is some c within 1, 3 such that f of c equals pi. And that's how you prove it. So limit laws now. Given the limit as x approaches a of f x equals 3 and the limit as x approaches a of g of x equals 4, use the limit law to show all. So remember, using the limit laws, and we got to show all of this. So use the laws. So this first one, don't just plug in 3 and 4. You actually got to use the laws. So I could separate it. Limit as x approaches a of f times the limit as x approaches approaches a of g of x, which is going to be, now this is 3 and now this is 4. So that is 12. Next one, same idea. I can use them all to pull the radical out. So this is going to be the radical radical limit as x approaches a of 4gx. Still not done though. I can't plug in 4 because there's a 4. I can't plug in my value because there's a 4 in the way, so I gotta pull that out. So it's a radical 4 times g, the limit as x approaches a of g of x. Alright, so you gotta use limit laws, right? 4 only equals the limit of g of x. You can't just plug it in willy-nilly. You gotta make sure you get to that part, and now you can plug it in. So this is just 4 times 4, which is 4. Square root of 16 is 4. Same thing here, right? Can't do it yet. I gotta break it up. So the limit as x approaches a of x squared times the limit x approaches a of f of x. Now here I don't have to worry about the same rule because it's just an x. We know how to do those. It's a continuous function. I can just plug it in. X squared is a continuous function. I can just plug it in and I get a squared. Then here, they tell us what that value is. As x approaches, that's my a. As x approaches a, it's 3. So I get 3a squared. That's my answer. Again, the key to that one is to show limit laws. You have to show the actual limit laws to get all your points. Suppose you want to find the horizontal asymptote of this function. Set up and evaluate the correct limits that yield horizontal effects. The limits you evaluate are called, well, if we're trying to find horizontal asymptotes, they're called limits at infinity. So I'll be doing like limit as x approaches infinity of f, and the limit as x approaches negative infinity of f. Those are called limits at infinity. Limits of infinity is when your answer is in infinity. Evaluate the following limits. So we just gotta evaluate these guys. So k goes to e of k. So in this case, k is a variable. So all we have to do is plug that in. So we just get e. Done. 0 from the right of this. Now notice there's no variable to plug in. So I just get, it's a constant. E pi is my answer. Next one. T goes to a of this stuff. Well, just plug it in. So a squared minus 2a minus a I can add these up and I get a squared minus 3a. Done. Next one, so all we have to do is plug in pi over 4, 5 pi over 4 into both x's. But if you do that, before you do that, don't you notice x sine squared plus cosine squared? It's an identity. This is just 1. Sine squared plus cosine squared just equals 1. So you're just plugging pi over 4 into that, and you just get 1. Again, it still works if you do sine squared of 5 pi over 4 plus cosine squared of 5 pi over 4. In the end, you just end up with 1 also. So do you want to do more work or less work? And then we do the next one. Now this is limit at infinity. I'm going to mention this a lot. Limits at infinity are special. Right? These, you don't just plug stuff in. Look at the powers. What power is bigger? So in this case, we're looking at these guys. That's x to the 4th over x squared. Right? Square root of x to the 4th is x squared. So the top is bigger. Essentially, we just get the limit as x approaches infinity of x squared. If you plug that in, you just get infinity squared, which is infinity. Next one, again, same type of problem. So going to infinity, so all we care about the highest powers. So this is like saying limit as x approaches infinity of negative x squared over 3x squared. So it's the same ratio. So it's just getting negative 1/3. Next one's another infinity one. So again, highest power. Now in this case, top factor is multiplied for you, so we gotta do that ourselves. Multiply this by this, we get 2y squared. Multiply this by this, you get negative y squared. So another ratio, and I get negative 2. I'm not sure why there's 2 equal signs there. Next one's not an infinity one, it's 2. So sorry, negative 2. It's negative 2. So first thing I want to do is sub it in and see if it works. So sub it in, you get negative 2 squared minus negative 2 minus 6 over negative 2 squared, which is 4, minus 2 times negative 2 minus 8. So I'm going to get 8 minus 8, and I'm going to get 6 minus 6. So yes, it is 0 over 0. So that means we've got more work to do. So let's factor the top. Limit as x approaches negative 2. I can factor that to be x minus 3, x minus 2. And on the bottom there, it's x minus 4, x minus 2. X minus 4, x plus 2. These are both be pluses, by the way. Sorry about that. Only way to get the negative to have different signs. So this should have been 4. Man, I just messed that all up. X minus 4, x plus 2 is what I meant to put. These cancel. Now I have the limit. X approaches negative 2 of x minus 3 over x minus 4. Sub in negative 2. I get negative 5 over negative 6, or just 5 over 6. Next one. So same idea. Limit as x approaches 3. First thing you want to do is like sub it in, see if it works. I get 12 minus 12 over 9 minus 21 plus 12. So I get 0 over 0 again. So it doesn't work. So it is with the little plus sign. So I have a couple ideas here with the plus sign. You could either factor cancel, see if it works that way, or you could graph it if you know how to graph this. In this case, most of the time, if it's something basic, say graph. In this case, I'm just going to try factoring it. So I think it's going to work. So let's just try factoring it. Should like everything else. Factor out of 4, x minus 3. Factor at the bottom to be x minus 4, x minus 3. These cancel out. Now you can plug in 3, and you would get 4 over 3 minus 4. So 4 over negative 1, just negative 4. So it works out. So most of the time you see a little plus sign, you want to graph it, but in this case, if it works, it works. 17. H goes to 0. When you plug in 0 right away, it's 0 over 0, so it's not going to work. We got to work on this. Now there's no shortcut to this, you just got to simplify it. Let's expand this. 2 plus h times 2 plus h. And you're going to get the limit as h approaches 0. Remember, you keep on writing it until you actually plug it in. You get 4 plus 2h plus 2h plus h squared minus 4 all over h. Now, stuff should cancel, like 4 and that. You get the limit as h approaches 0. I can add these together. 4h plus h squared all over h. Now, the whole goal is to plug in 0 again. I still can't plug in 0 because I get zeros everywhere. but I can factor an h out of the top. Limit as h approaches 0 of h plus 1 plus h. Wrong. Factor h on top, I get 4 plus h is what I meant. All over h. These cancel. Now plug in 0. And you get 4 plus 0, which is just 4. Next one. Right, so plug in 9, I get 0 over 0. So it's not going to work. So remember, two ways to do this. You could either factor the bottom, or if you're good at it, or you can multiply the conjugate. I'll do the conjugate because I think that's what most people are comfortable with. So multiply both top and bottom by the conjugate of the top. Conjugate of the one that has a radical. Now on top, the difference in two squares. So let me write this first because you have to write that still. So I'm going to get x minus 9. Over the bottom is x minus 9. And then times it by rad x plus 3. Right, so this times this got me x minus 9. This times this, you just want to keep them separate to get that. These cancel, there's still 1 on top. So I'm going to write that just in case you don't get confused. Then you plug in the 9. So I get 1 over radical 9, which is 3 plus 3, which is 1 over 6. So there you go. Number 19. Getting uglier and uglier as we go. So it's another one where you gotta multiply the conjugate. It's an ugly radical. Well, first plug in 8. I would try to trick you. If you plug in 8, I get a 0 on the bottom, but let's see on top. I get 8 minus, so I get rad 6 minus rad 6. It is 0 over 0. No luck. So let's multiply by the conjugate. So same idea. With the radical, we can multiply by the conjugate of that. So x minus 2 plus 14 minus x. All over x minus 2 plus 14 minus x. Welcome to calculus. So you have limit as x approaches 8. You multiply these, get different two squares. So these two would cancel out, you just get x minus 2. And the middles all cancel, and then you get minus 14 minus x. Make sure the minus is there, very important. On the bottom, just keep it the way it is. Keep it x minus 8, that's probably going to cancel, and then all this mess. Like that. Right, the whole idea is that this should cancel out in a second. So by the top, remember it is a minus, so it's going to be, this should be that negative both, so it'll be x minus 2 minus 14 minus x. And then if we do that, plus x, right? The double negatives makes them positive. So if we do that, I'm going to write right here. Limit as x approaches 0. Add the x there, I get 2x minus 16 over the bottom. And now I can see it. That. Look at the top there. I can factor out a 2. So it becomes 2x minus 8. And now the x minus 8's cancel. You have the limit as x approaches 0 of 2 over this mess. It's an 8, by the way. 14 minus, oops. 14 minus x. Plug the 8 in. Remember, the whole point is you want to plug in the x. That's the whole point of this. But you just can't do it when you get 0 over 0. And now we don't get 0 over 0 anymore. So we have 2 over rad 6 plus rad 6. We did that earlier. So I get 2 over 2 rad 6. So I just get 1 over rad 6. Like that. No need to rationalize or an AP Calc. Next one. I mentioned some lot. I was like, you're going to get this. So this is the next one. Plug in 0, you're going to get 0 over 0. So we got to fix it. Remember, the only thing we got to do is common denominator. So then we'll multiply this by 4 plus h, 4 plus h, and then 4 over 4. So we're going to get the limit as h approaches 0 of 12. Again, I show more work than you have to. This shows some work, but you can't go crazy like I do. So make sure everybody's in the right spot. Alright, so this part you could skip. You could skip this and combine. So common denominator, 4 plus h, 4 plus h, 4 and 4. And I get this. Combine these, so you're going to get the limit as h approaches 0 of, don't forget this should be the negative, very important, 12 minus 3h. All over 4 plus h. Remember, all this is over h. But all you're doing is dividing. That's all that is. So I'm just going to write right here, divided by h. So just make it a little easier to see. Now look what happens. These cancel out. all we have is the limit as h approaches 0 of negative 3h over 4 plus h dividing by h. So I'm going to multiply by that. So dividing by h, multiply by the reciprocal. These cancel out, and you're left with almost there, almost on this one. Negative 3 over 4 times 4 plus h times 1 over, that's gone to 1. So you get this. Remember the whole point? Plug in your limit. All we want to do. So we get negative 3 over 4 times 4, which is negative 3 over 16. So there we go. We're not done. We got more to do. This stuff's fun. Next one. Limit as h approaches 0 of 2e to the x sine 3x over x. So plug in 0 first. Sine of 0 is 0. So it's going to be all 0, and that's a 0 on the bottom. So that's not going to work. So let's separate it. This is like a trig derivative, actually. So let's separate it. Let's try to get the trig out of the way of everything else. So limit as x approaches 0 of 2e to the x times the limit as x approaches 0 of sine 3x over x. Just like that. Remember, there is a rule here to get rid of the x, to get rid of this, make this 1. That is, at the top and the bottom match, then it's 1. So if this is a 3x down here, then it's 1. This is fine. Plug 0 in there, you just get 2. This I've got to worry about. So remember the way we fix that to get the trig limit? Multiply both top and bottom by 3, so that I can move the 3 right here, and I can move this to the front. So we're going to get this in our next line. The limit as x approaches 0 of 2e to the x. By the way, we're going to skip this one. Something we don't do in this in AP. The limit as x approaches 0 of sine 3x over 3x. Remember, that's the whole point. I can't bring this into here. This is locked in, so you just got to move the 3 here and move this to the front. So get this. All of this is 1. This right here, just plug the 0 in. You get 2e to 0 times 3 times 1, which gives us 6. 6. The 0 is 1 also. So there we go. Let's move on. 4 from the right. Okay, so let's plug in 4 this time to see if it works. And you get 2 minus 4 over 4 minus 4 squared, which is negative 2 over 0, which does not exist. That does count. That is the right answer. But if this is multiple choice, and I want, let's say this is multiple choice, and it's A, B, C, D. Now it'll be more descriptive. They don't have, and it does not exist as an answer because they want you to be more descriptive. Is it plus infinity? So basically they're asking, is it plus infinity or negative infinity? How do you do this? Well, 2 ways. One, you graph it if you're good at graphing it. I'm not sure if I'm good at graphing this one. Another way is try something close to 4, but to the right of 4. If it's positive, it's positive infinity. If you get negative, it's negative infinity. So let's try 4.1. So I plug 4.1 in there. 2 minus 4.1 over 4.1 minus 4 squared. Over here I get negative 2.1 over 0.1 squared. Right, so negative 2.1 divided by 0.1 squared. Remember, if you divide by a small number, you get bigger, so it's going to be infinity. It's not going to be that. You're getting close to it. But the key here is to be negative. So you get a negative number, so it's going to be negative infinity. That's not negative 8. Negative infinity is going to be our answer. Why did I come and do negative 8? Negative infinity. Finally. So it'll be negative infinity. Again, as long as this is correct, but some problem like this, if I was trying to make it like the AP exam, I'll put a little multiple choice at the end, and I won't give does not exist as an option because they want to be more descriptive. So it is does not exist. That is totally right answer. For your response, that's fine. If it's multiple choice and you don't see that there, then they want to be more descriptive. Is this a negative infinity or is it a positive infinity? In this case, it was negative infinity. Ooh, a challenge problem. They do like to ask this question on the AP exam. Find all the horizontal asymptotes of the function y equals 5 plus 2x and y equals minus 2x. So basically they're saying, what is the limit as x approaches infinity of f? And what is the limit as x approaches negative infinity of f? So, as you approach infinity, you're plugging infinity. All you're doing is looking at the highest power. As you go infinity, that's the rule, highest power. So in this case, we're looking at 2x over negative 2x. So I get negative 1. Right? Because all we're doing, we go as you go to infinity, and it's like these. Which one grows faster? Grow the same rate. Negative 1. This one, negative infinity, is not so nice. You can't do that for negative infinity because these graphs are different. So when we have negative infinity, we want to look at the graph of these guys. So what's going on here? 2x looks like this. But remember, we're going to negative infinity. So that's a 0. Negative 2x will be the same thing, just flipped. Negative 2x, same graph, just flipped upside down. So I have to go negative infinity, also 0. So this turns out to just be 5 plus 0 over 1 minus 0. So just 5. Right? It's tricky. When you go to infinity, you're looking at, okay, which one grows faster? They grow the same rate, but they're different. Like, it's like ratio, right? So this is a negative, so negative 1. When you go to negative infinity and it's not a polynomial function, you want to look at the graphs and see what happens. So in this case, if you go negative infinity, this is actually turning out to 0, and that's turning out to be 0. Anytime you have an exponential graph and you're going to negative infinity, it's going to 0, because that's the way the graph works. So really it just turns out to be 5 over 1, so 5. And that's the worksheet, or that's the study guide, I should say.